When adding an electrophile to an unsymmetrical alkene, Markovnikov's rule says the electrophile attaches to the carbon that already has more hydrogens, so the nucleophile ends up on the more substituted carbon because that pathway forms the more stable carbocation intermediate. Think of the double bond as two friends holding hands and an incoming electrophile as someone who will hug one friend first. The electrophile prefers to hug the friend who already has more hydrogens, because breaking the bond there makes a carbocation that is more stable when the positive charge can sit on the other carbon, which has more alkyl groups around. More alkyl groups push electron density toward the positive site and stabilize it, so the reaction naturally goes that way. When the carbocation is more stable, the second step where the nucleophile attaches happens faster and more often at the more substituted carbon. So the observed product places the new group on the carbon that was more substituted, and the hydrogen ends up on the carbon that started with more hydrogens. Students often think the rule is a magical law rather than a consequence of carbocation stability, and that leads them to forget to consider situations where rearrangements or alternative mechanisms change the outcome. Check whether a carbocation rearrangement could give a different, more stable ion and then predict products from that. Another common mistake is applying Markovnikov's rule to reactions that do not proceed through a carbocation intermediate, like hydroboration, where the addition is anti-Markovnikov, so identify the actual mechanism before using the rule. Some learners also overlook the effect of solvents and substituents that can stabilize or destabilize intermediates, so always think about the whole reaction context when predicting the major product. For more videos and resources on Markovnikov's rule and related reaction mechanisms, check out www.gumballdegree.com.